Hello, everyone, and welcome to today's webinar. We will start in just a few moments from now. Thank you. Hello, everyone, and welcome to today's webinar. As you all know, today's webinar is on mill turn and Swiss type CNC machine fundamentals, and it will be given by Ivan Cimr from SolidCAM CZ. Now, this webinar is also being recorded as usual and will be available later on our website. So without too much hesitation, I will make Ivan the presenter. And Ivan, you can go ahead, share your screen, and start.
Hello, everybody. Hope I'm sharing the right screen.
No, you're not actually. We see your boat.
That's my boat is not the right thing, so I try to change. Sorry.
Okay.
It's correct now.
Right now, all we do see is just your boat.
That's boat. Okay. How can I change the screen I'm showing? Because I have
Okay, will you see the button that says show, and under it says
here.
screen with an
Okay.
arrow.
Okay. Now I think it's okay now.
Okay, that's it.
Thank
You're
you.
okay now.
So once more, hello, everybody. Today lecture is about Milton machines and Swiss type machines. It's for a few years, SolidCAM is developing more and more features for these machines, but there is many resellers and salesmen struggling with this topic. So I try to create a lecture which can help you to get the basic terminology and basic view, so that you are not afraid of this issue, because I learned that this is a problem of some salesmen with not so experienced with this machinery, that these machines looks a little bit too complicated. So we are today going to talk about fundamentals, really basic things. And as you see on the picture, I am going to start on a really basic issues. So what we are going to talk about, fundamentals, almost for beginners. So if you are already experienced, don't waste your time. It's something you probably already know, or of course you are still invited. Repeating is a wise thing. So it is intended for salesmen to understand the basic of advanced Milton and Swiss type. In Czech Republic, Slovakia, there is many resellers with salesmen who are not specialized in CAM. They sell SolidWorks, they sell other type of products, but they are also supposed to sell SolidCAM. And so they are not meeting these advanced machines too often, maybe once or twice a year. For them, it's not easy to go to complicated machines, and for them is this webinar intended for. Because this salesman still wants to sell Swiss, the most advanced things. We are different from our competitors. Or anyone who simply wants to move up into multi-channel world, maybe it's already selling, but not these complicated machines. This is a beginning of this issue. Don't please forgive me if I'm going to be really basic. Sometimes it's necessary. Sorry. We are going to deal with turning and milling. The short video about this. I see that the video is not pretty moving too much. Don't know how you see it.
Videos usually don't run well within.
And I'm sorry. So there are some videos, and probably we are not going to use them too much. Okay. Okay, what machines and what configuration of SolidCAM we are typically meeting in our world? We all started on milling machines. I'm with SolidCAM for 19 years, and that time the turning was really not an advanced issue for anybody. Not was multi-axis, okay? But milling machines or milling centers today are a common machine for us. So is turning machine or lathe, which provides turning capability. Again, simple machines. Combination of these two capabilities we use first on mill-turn machines. Mill-turn, we usually say about lathes, which provides also turning and milling driven tools. Turn mill we have for machines which are basically milling centers with some turning ability, like Hermle MT. Okay, Swiss type, it's a special case of mill-turn machines, special features. Okay, and we will be talking about these two, about mill-turn machines and about Swiss type machines. And we will try to define them and try to tell what is the difference, both technologically and also from a SolidCAM point of view. So let's start. Fundamentals of lathe. Again, there is a video which I will skip because it's not working properly, but it shows at least turning tool. You know, turning, it's something where tool is more or less fixed on a linear path, and the stock rotates, part rotates. While milling, it rotates the tool, of course, but this is common classic lathe. Okay. Before I show you some advanced machine, I'm showing you this machine. This is how lathe is basically designed for hundreds and hundreds of years. I'm not exaggerating. This is 1218. Oh, that's an old one. But if you see, it looks exactly like today. So it's a really, really old design. And every part on this machine has certain tasks, certain name. Let's talk about a few of them. So, spindle. Spindle is this part. Please don't mistake it for this upper part, which is a clamping part. In this case, it's called chuck. There are several more options in which you can clamp your part. Chuck is maybe the most common, but this whole part, where is also an engine, it's probably hollow so that you can stick the rod inside. This is main spindle. Opposite to the main spindle, you can see the tailstock. On a modern machine, you will probably find a second spindle, but not every time. So it's a tailstock. You put some sharp device in it, which is called a dead center. It's a tailstock. It's a tailstock. Tool post. It's this one. This is where the tool is located, where you put the tool, clamp it there, and then you cut with this. It's basically a tool holder. And finally, XYZ controls are there. It's a manual machine, so it's not CNC. But this is where your CAM program comes in. if you have a digital control, NC control, okay? But here you have wheels with non-uses and everything, okay? It's an old machine. So this is how a typical design of a classic lathe look. Again, there is a spindle, there is a tool holder, there is something like on the opposite the spindle where here is a tailstock, and there is something which is moving with axis. And again, the video is not going to work, but this is let's take it as a picture. You see, this is how such an old lathe looks. Okay, and now this is pretty simple picture. One spindle, one tool in a holder. Yeah, it's simple. Now you visit your customer and you see such a frightening picture. Oh, it really looks complicated and dangerous. So many sharp pieces, you know, and it's a cramped space. It's not enough space inside. You have a feeling that everything must crash to anything in a moment. It's really complicated. It's frightening, and I fully understand that your feeling is like this. Okay, that's not the best emotion because we need to sell. So don't worry, it's going to be simple. Let's start fundamentals of Miltons. Modern Milton machine can look like this. Such machines, they are everywhere. Mazaks are very famous in Milton. I remember Mazak Integrex machine was a famous word in my company for something which we cannot reach, which we cannot handle many years back. And then I remember Integrex was one peak SolidCAM has to climb before going up upper and upper to the Swiss type machines. But once the goal was Integrex machine. Simple today, simple Milton machine with 2 spindles and 2 turrets as at most. Okay, I said turret. What is a turret? Turret is a tool post. It is where the modern lathe has tools. And regardless whether it is a turning tool, which is a fixed tool bit, or if it's a driven tool, it's like any milling tool, right? So this tool holder, which is rotating, holds the tool, very different tools. So it's both storing device and also cutting device. So this is tool post on a modern machine. This is the machine with the rotary turrets. Actually, this machine has 3 in a different configuration again. And again, it looks complicated. And also notice there are 2 spindles, main spindle, and this is what we call back spindle. It's easy to remember back spindle, right? This is where the tailstock used to be. And 1, 2, 3 rotary turrets. That is something which you don't see on this picture too well, but on the left picture you can see it. There is also on the other side of the rotary turret, there is a spindle turret, but we will see it later. This is machine with linear turrets. That's just different engineering, but still nothing complicated. It's something which holds the tool, something where you can put both turning tools, both milling tools and drills, whatever, just tool post. And on this picture, it's not clearly seen that this is a spindle, and you see it's like a back spindle. It's from the right side, right? On this simulation picture, you can see that there is also another spindle. It's just not coaxial. not necessary. This is again, they're just different engineering, different design. Okay, but still you have only 2 spindles and several tool holders, tool turrets. 1, 2, 3, 4 turrets. Spindle turret. Oh, again, it's Mazak Integrex. And it looks like, well, basically you can mistake it for a milling machine, because what I see is a spindle which I can see also on a milling machines. And maybe on a very, very first look, oh, it's okay, it's a milling machine, probably more axis, because I see that the spindle can is on some rotary axis, but it's not a milling machine. It's mill turn machine, and it's closer to lathe, closer to turning center, because here you can see the main spindle like this, and from the other side there can be a back spindle, and also there can be a bottom turret. Yeah, sometimes the design of these machines, it's really hard to say what it is, but this machine is a military machine, and this what resembles you to just ordinary milling spindle, it can easily take turning tool or milling tool in and just apply it on the part. So now we know these types of tool posts: rotary turret, linear turret, and spindle turret. It's only something to hold the tool, not complicated. Just this. So very typical for modern military machines is not to be so complicated. No, mostly there are 1 or 2 spindles. Sometimes it's a spindle and a tailstock. Sometimes it's a spindle and a back spindle. So no more. And usually it is coaxial. And there are some tool holders, some turrets, different design, but just tool holders. So if you come to such a machine, then don't be afraid. It's not so complicated, and look at it with these eyes. Why there are more turrets? Why there are more spindles? This is because we need more productivity from these machines. For example, if you look at the right picture, then you see that 2 turrets are at the same time working on a part, while the third turret is working probably on the previous part from the other side. Then it can really speed up the process. Oh, we have to jump the video. I'm really sorry that you cannot see this video now, because it is showing very clearly how this machine is working on both spindles. But when you download this presentation, the video will most likely work for you. So you can download and you can watch it once more. And now, when you have more turrets and 2 spindles, and you want the machine to be working at the same time on 2 spindles with more tools, then you must be careful not to crash to anything. These all turrets has to work in a perfect synchronization to avoid collision. And this is what the SolidCAM comes also in, because there is advanced synchronization tool which can synchronize unlimited number of channels together and automatically. Let's go to Swiss. Swiss type machines. As you see, they look even more simple from outside. Nothing special. This Mazak Integrex, it was impressive machine. This looks like nothing special, but they are special. They are called Swiss type machines or Swiss type lathes or whatever. Nothing to do with Swiss today. The production is in Japan, in Korea, in Taiwan. Well, there's many other. So what is so special about Swiss type machines for us, and what is the complications with them? There is a little bit different thinking with these machines. On the right side, you see how the part behaves in a standard Milton machine, especially if it's a long and slim and small part. And this is exactly the type of part these Swiss type machines are designed for. Small, long, and that's it. The toughness of such part is really not guaranteed. So if you want to cut it productively and avoid deflection and vibration, on a Swiss type machine, mostly we used guide bushing. Not every time, but yes, it's common that there is a support inside the spindle, these bushings, which will support this bar stock and successfully minimize deflection and vibration. So this is one very typical feature for Swiss type machines. This is enough examples of typical parts being cut on Swiss type machines. Okay, typical dimensions are up to 42 millimeters, and the length diameter ratio is usually bigger than 5 possible. I mean, range of materials is a very big one. Typically, these machines are used for a really fast production of such parts. You are not measuring time in seconds, but in fractions of seconds. You are trying to get the time down as much as possible, and you produce you can produce a huge series of parts with this. Now, let's take more differences between Milton and Swiss type machines. Okay, you already know that we can control more devices, more turrets, which means you have to send for each turret, you can send one NC program. Every turret is working with one NC program. So you, for example, can read 2 or 3 NC programs in parallel at once to the machine, and machine is handling it. Okay, and each of these programs runs some dedicated device. Here, important note: number of devices and their axis movement is often referred as number of axes of the machine. So you can hear about 10 axis lathe. This is at best is very imprecise, but it's heavily used. We have 12 axis lathes. Oh, no, they have not. We usually deal with the 5-axis machines, and this is precise technically. 10 axis means they have more devices, and each device has some number of axes. But it doesn't mean that there is a 10 axis of freedom. Number of programs being read is referred as a number of channels. So remember, number of channels, number of NC programs you are able to send to the machine, okay? Important wording is axis pattern. This feature we will explain a little bit more later. This is how we share this axis between channels. And this is decisive for definition either Milton or Swiss type. Important is how we understand this differentiation in SolidCAM. It basically is only about a type of synchronization you have in your price list, and we have two. We have Milton synchronization and we have Swiss type synchronization. That's all. That's all you need to know, whether it's Milton or Swiss type synchronization. Milton machines can have unlimited number of turrets, 2, 3, 4, whatever. Typically, they have the same number of channels, not necessarily, but typically. But they can work only with one axis pattern. I will this axis pattern try to explain on a Swiss machine, okay? And these are typical Milton machines. Remember axis patterns, please. We are on a Swiss type definition according to SolidCAM. Again, here on this machine, we have 1, 2, 3, 4 turrets, okay, and 1, 2 spindles. Suppose that this machine has 3 channels, 4 turrets, 3 channels. On a Swiss type machine, you can choose which 3 devices, which 3 turrets will work with these 3 channels. So you are changing the pattern. You are defining these 3 out of 4 which are going to work. So maybe you dedicate 2 turrets to work on a main spindle and 1 turret to work on a back spindle. And then what about the 4th one? Okay, he is going to try to pretend that he is not here. So but you can change this pattern. You can dedicate these 3 channels to different 3 combinations. There is many combinations, and these combinations of turrets which are going to be driven by these 3 NC programs, it's called axis pattern. So Swiss type machines typically has different number of turrets and different number of channels. It typically can be 4 or 5 turrets and only 2 channels. Can be. But this still creates many combinations in using these turrets, but only 2 at a time. So this is Swiss type definition, while Milton has only 1 axis pattern. So if you come to Milton or Swiss type machine, you can really see funny design because the fantasy of these machine designers is endless. It can look frightening, it can look complicating, but it's still the same thing. There are spindles, there are turrets, okay? And you are a SolidCAM salesman. You know that SolidCAM can handle this easily. So trust yourself, trust SolidCAM. This is not complicated for us. Today, it's actually, well, standard. We can do it. And we already done many of such machines, okay? Yeah, it can be really complicated. It depends on a type of work these machines are intended for. Some are more simple. They can be sold in many different configurations. It's really flexible. So how you are going to handle it. Well, these are companies, some of them only, who are producing. Look, sales fundamentals for you to sell. Okay, when you are faced with such a complex machine, just try this. Ask reliable questions based on what you learned a few minutes ago. Ask about number of axes. Ask how many spindles, or you can just look inside. Ask about number of turrets, or try to count them yourself. Ask how many channels or how many programs they can send at once to the machine. And this is important for your technician if he is not with you. Ask exactly about the type, name of the machine and make it a note, because the name usually contains the definition of how this machine is assembled, what configuration of the machine it is, how many devices are inside. It typically could be inside its name. So ask about the name. There's nothing wrong asking a reliable question where they can understand that you are asking something you understand. You can count spindles and turrets yourself because now you know how it looks. But you can typically ask to show you the part they want to cut on it or they cut before. And now try to look for some possibly weaknesses. How much time they spend typically on programming? How much time? Who is doing it? Who is doing it? Is it the employee? Do they have CAM? How they are doing it? Because now you are in your own element. You can ask questions like, do you really still use manual programming? And you really depend only on one man to program the machine, which means it's dangerous. What about this man to leave the company or being sick? And you take only big serious because the programming takes so much time? Because with SolidCAM, you can significantly shorten the time of programming very much. So they can take other work with a smaller series, which is might be financially interesting. So do you have reliable simulation? No, you don't. Okay, SolidCAM can provide you one. This is the question you are supposed to ask, because Swiss type customers has some difficulties. The manual G-code programming is not easy. It takes time. It takes very careful approach. And without visual verification, it's they have to do it on the machine, slowly, carefully, and they have to do it properly because they know they want really short time. Okay, and there is only one man who can do it. It's perfectly dangerous because if there is no that guy, what we are going to do? Okay. From SolidCAM point of view, it's pretty simple because you don't need much from SolidCAM. You need turning, milling, 2Ds, okay. Machine simulation, if they want simulation, and multi-channel synchronization. If you take the more advanced one, then you covered everything. There are some options on top you can offer, but maybe later, maybe not. So it's not so much. SolidCAM configuration is clear. It's a Milton machine simulation synchronization. That's all you need for a multi-channel machine, either Milton or Swiss type. The other issue is a post-processor. Post-processor. That's not easy. You have to remember, you are SolidCAM reseller, and there is a SolidCAM team which is dedicated for creating post-processors and supporting you. There are many post processors ready to go on quite a lot of machines. If it's not, there is a team who is going to help you to create post processor. This is type of support that you cannot find anywhere else. This is really huge support with a big international team who can help you to handle such machines properly. Your task is to find the customer, to offer properly, and then deliver SolidCAM and post-processor with the help of this team if you have your own people. Okay. SolidCAM is choosing the Swiss type direction to be because there is a high market potential. There are a lot of such machines and there will be more. This is not the only reason. The reason is that having such capability is showing customers that SolidCAM is the most advanced system in the world. And this is something which can support you in selling other types of machines with SolidCAM. It's also a marketing issue. Yes, we can do this. Which system can claim the same thing? And these customers really need us. If they have these types of machines, they need us. This is about maybe they have SolidWorks or Inventor and they like integrated solution. But also they need something which really can handle these machines to shorten the cycle of programming, to be easy enough to understand, and also simulate. Very important issue is know-how, which is stored inside SolidCAM instead in a head of the only guy who can program the machine. You can make templates from a successfully programmed project, and all the knowledge, all projects will be stored inside SolidCAM. So if you have to change the guy, then you will just teach him to use SolidCAM, that's all. Who is our potential customer for it? I think we already covered this. Just this is one disclaimer. Not everyone who has Swiss type machine needs really a CAM system. If they are producing very simple parts and short parts, it's easy for them to create the program and cut. The more complicated part, the better for us. But we can also use this rule a little bit different. We can come to a customer, say, do you want to produce complicated part? Because probably financially it's more interesting than to be the producer of very, very simple parts. If I'm able to produce complicated parts, then I can probably get more money if I can do it easily enough, fast enough. With SolidCAM, this is possible. If you come to a customer and you see any type of Swiss type machine, you define it as a Milton or Swiss type machine, you don't have to be afraid about any kind of such machine. We know them. Any configuration we can handle. Whether it is complicated or not, we can handle. Complicated and advanced functions, we can handle. Multi-channel machines, we can handle. So don't be afraid. We can do it all around the world, and you don't have to worry that we are not able to do this. So this was about it. You can be bold enough now to go and sell to Milton and Swiss type industry. You have a CAM system which is best in the world in this, and we can, with our dedicated team to help you, we can probably overcome any problems you will have. Okay, thank you for listening. And as Sydney promised, there will be this presentation for download for you. If you have any specific question, you can reach me. Thank you for listening.
Okay, Ivan, thank you very much. It was very inspiring webinar. Again, everyone, thank you for joining us. And as Ivan said just now, and as I had said in the beginning, the webinar has been recorded and will be available for you to watch and download if you want to. Also want to on our website in the resellers area. Take care, everyone, and have a great week. Bye-bye.
Bye.